Yes guys, so we are doing question number 3 here. What is question number 3? The third question here. I have already described that this is a circle in which the first quadrant of this circle between the circle and the line x equal to a. X equal to a is the line this. Okay, so what are the limits for theta we have taken? So theta is from this point to this point. That means this is the middle point. Here y is a, x is a, this is a point, the x equal to a here, y is also a. This is the middle point of this circle. If I take the circle like this whole, okay, so this circle is, up to this midpoint. Because of that, theta is from 0 to pi by 4. The limit of theta 0 to pi by 4. And I have described already, because x equal to a, if I substitute x equal to r cos theta equal to a, r is equal to a upon cos theta, that means a sec theta. This is the lower value of r here, because we have to take this first quadrant between this line and this. So this is the portion which we are finding out, the first quadrant, one quadrant or first quadrant of the whole circle. We are finding out the area of this first quadrant. Now below, the area of the first quadrant will be pi a square, because a is the radius, pi a square upon 4. So that area we will take. Only this first we have to find out. What is the area of this portion? The mean value is of this ordinate. This is y here with the point. Obtain the R.M.S. root mean square value of the distance from the r. This distance r in the first quadrant, okay, of the first quadrant of the circle. We have to find out that. Okay, so the area of this first quadrant, because it's talking about first quadrant, value of the distance from the origin of the point within the circle, this one, cut off by the line this. Okay, so only this line is cutting in the first quadrant here. We have to find out that root mean square value. Okay, obtain the root mean square value, okay, of this point. That is the point r here. So r square that we will take here. So r square we have to put. This is r square r g dr d theta. Alright. So this is the value. Why? Because this r square, root mean square value, we have to find out the square root of this whole value. This is y into ds. Okay, and dx is dx d theta, because this is the area here. So r square r d theta dr. Okay, r square is the distance of this point. So r is there. Now, what are the limits for r and theta that are described? That r is from a sec theta to r is equal to a to a cos theta. This one from the given equation. X square plus y square equal to twice a x. So this is r square x square plus y square r square equal to twice a x. X here is r cos theta, so r cancelled out, so r equal to a cos theta. Limits for r, a sec theta to twice a cos theta that are taken here. The root mean square value is equal to square root of r square r dr d theta divided by this area of the circle, quadrant of the circle. So area of the quadrant of the circle means this whole value that I'll calculate, that this is nothing but pi a square upon 4. Pi a square upon 4. Pi a square is the area of the whole circle, but area of the quadrant of this circle, this quadrant, the first quadrant here. But in the first quadrant, we are finding out this distance. So this is the area A. In the denominator, we will substitute this. This is the whole area we have to calculate. Even after solution of this, we will get this pi a square upon 4. The area of the quadrant that we will take. In the numerator, I have to now solve. Let me solve the numerator here. Okay, so numerator of this equation, root mean square value of this distance r here. So R.M.S. root mean square value of r, the distance of the point, okay, within this that I have already described, within x equal to a and the circle Okay, between this and this. So root mean square value that we are calculating here. That means this is nothing but root mean square value is square root of that we are calculating here. So theta limits for theta is theta equal to 0 to pi by 2. This is the middle point, x equal to a is a line, no problem. But y limits are from this point x equal to 0 to this point. This point is at x theta equal to limit for theta, I mean sorry, theta 0 to pi by 4. Limit theta 0 to pi by 4. Here I am taking the numerator. Let me take numerator, because denominator is nothing but area, which is this one. This is the area here that we will calculate this value. So R is a secant theta twice a cos theta, okay, into R square means R cube here, R cube dr into d theta. So let me calculate this numerator only of this value. Now denominator we have the area here. The denominator d is equal to square root of the area. Okay, that is pi a square upon 4. This is the area here. That will substitute here when we divide. Square root will apply on both numerator and denominator. This is the denominator. This are secondly I will take the area of the denominator value is this much, because area we have to calculate this quadrant. Area of the quadrant here, which I have calculated here, area of the quadrant. Area of the quadrant is equal to pi a square upon 4. This is the first quadrant which we are dealing with 0 to pi by 4 of this point, which we are calculating limits for theta here. And R is from x r equal to a sec theta to r equal to 2a cos theta. These are the limits. But let me solve it. This is r cube here. R cube is r4 upon 4. Okay, within the square root. And this is limit now 0 to pi by 4, which is left over. And this is d theta only. Limit now is a sec theta. A sec theta to twice a cos theta. Okay, so these are the limits here that we will substitute and under the square root. So let me solve it. So denominator area of the quadrant here, which is a pi a square upon 4. This is the value of denominator. Denominator here is this equal to a equal to pi a square upon. This we will apply finally this area. Okay. Now we are calculating the numerator of this root mean square value, which is this one. So I have to substitute the limits here. 0 to pi by 4. Now R4 1.4 if I take outside, let me take 1.4 outside. Okay, or if I just calculate the value and after that I'll apply the square root, no problem. The square root I will apply after that. This is numerator we are calculating. The numerator value we are calculating here is this. It's still square root I am not applying. Finally I will apply the square root when I find the square root value. And numerator is this value, inside value. Okay, not square root I am not applying still. So this is 1.4 are taking common. The R4 is this. That means twice a cos theta whole 4 minus a sec theta whole 4 d theta. Okay. Now this is twice a cos theta. So 2, 4, 1.4 here, 0 to pi by 4, 2, 4, 2, 4 means 16, 16 here, A4, this is the first case, A4 here. Now cos 4, so this is cos 4 theta, limits are 0 to pi by 4 into d theta. Now let me separate these two values. This is 1.4 was here, so 1.4 will also be here. Limit 0 to pi by 4. This is A4 only. A4 only. Here this twice a cos theta, the upper limit. The 16 is only here, not in this case. 2 to the power 4 is 16. That are taken separately. Now this is sec 4 theta into d theta. Now let me solve them separately. Okay, so let me solve them here. Okay, so numerator we are calculating value of numerator. Solution here is this value 16, that means 4 into A4, 0 to pi by 4 cos 4 theta, where at cos square theta whole square, that means cos square theta whole square into d theta minus sign, the last one is A4 upon 4. Now 1 sec square theta can be written as, let me write 1 plus tan square theta. 1 sec square theta is 1 plus tan theta into second sec square theta. So it is sec 4 theta. Sec 4 theta can be written as sec square theta into sec square theta. 1 sec square theta is equal to, since sec square theta is equal to 1 plus tan square theta. This we have right here, 1 sec theta, sec square theta, this value. Okay. So now let me further solve it. So here we obtain 4A4, this one. Now what cos square theta? Cos square theta can be written as 1 plus cos 2 theta upon 2 whole square, upon 2 whole square into d theta. Cos square theta is equal to 1 plus cos 2 theta upon 2. We know that 2 cos square theta since equal to 1 plus cos 2 theta. Okay, so this is this value. So therefore cos square theta is equal to 1 plus cos 2 theta upon 2 whole square. So this whole square, 2 square will give us 4 here. This 4A4 upon 4. This 2 square are taken outside. 0 to pi by 4. Okay. Now this is 1 plus cos 2 theta whole square. Okay, so I have to open this 4. And I'm sorry, this minus sign here. A4 upon 4. Now if I put tan theta equal to, putting here, let me write tan theta is equal to, take tan theta equal to t, let me take, let tan theta equal to t in this case. So sec square theta d theta equal to dt. Okay, now limits at 0 it is 0. Limits are at theta equal to 0, lower limit, t equal to 0, at theta equal to pi by 4, at theta equal to pi by 4, tan pi by 4 equal to t, or 1 equal to t. Okay, so limits are 0 to 1 in this case. Second part. For 0 to 1 limits, there is 1 plus t square into dt, for sec square theta d theta. This is differentiating with respect to t here. Differentiating with respect to t. This we have obtained. Okay, so d theta upon dt equal to 1, or d theta equal to dt, sec square theta d theta equal to dt. Okay. So now in first case, this is 1.4 I have taken here. Now if I open this whole sphere, let me open that. It is only A4. 4 to cancel out, this is A4 only. Okay, now 0 to pi by 4. If I open this whole sphere, you will get it 1 plus cos 2 theta. Okay, 1 plus cos 2 theta plus cos square 2 theta d theta Okay, and minus this value, minus a square upon 4. I'm sorry, this are not written here. Just 0 to 1, 1 plus t square into dt. It was there. So what about this? Now let me write here a4 upon 4. This value 1 means t, that means t plus tq upon 3, limit 0 to 1. 1 plus 1.3, that will be. This is nothing but a4 upon 4, 1 plus 1 upon 3. This is the value. Okay, so up to this point. Now second, this a4 common throughout, but let me take in the first part. If I differentiate, these two can be differentiated with this cos square 2 theta. If I change the limits here, 2 theta, put phi or t, if this will be pi by 4, then it can be integrated, no problem. So let me integrate the first two parts. This is 1 integration theta, plus this is 2 sine 2 theta upon 2 integration of cos 2 theta. Now here limits are 0 to pi by 4. Okay, plus this second part, a4 is 0 to pi by 4. Also square 2 theta means 1 plus cos 4 theta upon 2. Okay, now d theta. And this is minus a4 upon 4 into 3 plus 1, 4 upon 3. This is, sorry, 4 cancelled out, I'm sorry. 4 cancelled out, not 3. It's a4 upon 3, last one. Now here, integration can be done now. Okay. Now let me further integrate it. Okay. So numerator we are calculating. So this is a4. Theta is pi by 4. So this is going to cancel out here. It will be pi by 4. In place of theta, that 0 is 0. What about sine 2 theta? If I put pi by 4, it will be sine 2 theta. Sine theta by 2, that means 1 only. Plus, it will be 1. At 0, it is 0. At 0, it is 0. Plus second part. A4, let me take common outside. What about this one? This is 1 upon 2. 1 integration is theta, so that will give us pi by 4 here again. This is because theta integration of 1, then putting the limit upper limit pi by 4, that will be there. Now cos 4 theta integration will be a4 upon 2, cos 4 theta means sine 4 theta upon 4, limits 0 to pi by 4. In both the cases it is 0. Why? Pi by 4, sine 4 theta is sine pi 0. At 0 it is 0. This whole value is 0. Cos 4 theta will be 0. Now minus sine a4 upon 3 only, the last one, last step. Now in this case, this cos 4 theta, sine 4 theta, and when we substitute the limit 0 to pi 4, at pi 4 it is sine 4 theta, 4 pi by 4, 4 cancel out, sine pi 0, at 0 it is 0. In both the cases it is 0. Only up to this value, we have opted a4 common, let me take 2 out common, it is 1.3 minus 1.3 will be there. Okay, so a4 common, pi by 4 plus, this is pi by 8 plus 1 plus pi by 8, this value, and this is 0 here, a4 upon, okay, this is last one, minus 1.3 only. This value is completely 0. This minus a4 upon last one, a4 upon 3, that means 1.3 a4 are taken common. Now let me see that what is this whole value. This whole value will give us A4. This is pi by 8. So 8, if I take LCM, it will be 2 pi plus pi means 3 pi by 8. And minus sign, this is 1 minus 3 by 1 by 3. 3 minus 1 means 2 by 3 plus sign. Is 2 by 3 here. No problem. 3 2 by 3. Because 3 minus 1, that means 2 by 3. Okay. Numerical values, and this is pi by 8 and pi by 4. This is the total value of numerator. Now let me find out what is the denominator, as I have already solved. That was the area of the quadrant of the circle. Area of the quadrant of the circle. So D denominator is equal to A, the area of the quadrant. Let me write here area of the quadrant. So this is area of the quadrant of the circle. Quadrant of the circle. So this is equal to pi a square upon 4. Simple. Pi a square is the area of the circle, and quadrant is 1.4 divided by 4. So this is pi a square upon 4. So denominator is this. Therefore, root mean square value. Root mean square value of the distance of R, is equal to square root of whole square root. It's a numerator. That means A4, that in bracket 3 pi by 8 plus 2 by 3 divided by this pi a square upon 4. Okay, so this pi a square upon 4, and this is this value. Okay, a square upon. Okay, these two are summarized here. Pi square upon 8, no problem. So this 4 will come in the numerator here, and a square, this is a square will be left, and the 4 will come here. Let me write here 4 inside. If I take 4 inside and pi divided by pi, it will give us, let me solve here. So finally, root mean square value. Therefore, the root mean square value of R distance is equal to, so dividing by this is A4 means A square, only A will come out. A square, because this is A square, and A4 means A square left over. A I have taken outside because square root of A square is A. So this 4 will come in the numerator. So 4 into 4 upon 5 here. So 3 pi by 8 plus 2 by 3. We will multiply by 4 by pi inside. So what we will get? A under root. This is inside here. So 2 only, pi cancel out. So this is 3 by 2 plus this is 8 by 3 pi. Okay, so this is the value of the distance R taken R distance here, of the point inside this quadrant from the origin. So that is the distance R here. This is the value of that. This is the answer here. The root mean square value. Find out to obtain the root mean square value of the distance from the origin of the points within the circle is cut off by the line this. In this quadrant, we have to find out the of a point, any point, distance of that from the origin R we have taken. This is equivalent to this value. This is the answer here. So A 3 by 2 plus 8 upon 3 pi. Okay, this is the answer here. Question number 3 we have solved. Now let me talk about what is the question number 4. Now question number 4, let me talk about. The root mean square value means square root of whatever the value of t. Okay, let me take this. Okay, so that was 3 by 2 plus 8 upon 3/5, no problem. That was answer here. Okay, that is the proper answer. Now let me take question number. Oh, let me clean this board. If I clean this, that will be better. Okay, now question number 4 is, what does it say? What does it say? Let me check. Okay, now question number 4. Question number 4 is, what does it say? Now it says find the mean value, okay, and the root mean square value. Okay, both we have to calculate here. Mean value and the root mean square value, both we have to calculate here. Of the ordinate y, of the cycloid x equal to this and y equal to this, between the two consecutive cusps. Okay, so between the two consecutive cusps, that means this one is cusp, second is this consecutive cusp. So limits will be into consecutive cusps. Let me take this and this like this. These are two cusps here. So limits will be from this point to this. Theta will be here. If I take theta equal to, or let me take y coordinate here. This is ordinate. I'm sorry. This is y we have to take. This is y equal to from this point to this point. Okay, so limits for y coordinate will be minus pi to plus pi plus pi here. Okay, so what is the root mean square value? First mean square value, let me take what is given to us. Question number 4 given here. What are the ordinates here? Okay, y is the ordinate, and the cycloid x equal to a into, okay, this is theta plus sine theta, and y is equal to a into, okay, 1 minus cos theta. No problem. Between the two consecutive cusps, this cusp and this cusp. So between these two we have to find out y is equal to minus pi to plus pi, the limits. Because ordinate is y. So we have already calculated the limits of y here. Okay, so between the two consecutive cusps, and show that the letter is under root 2 times. That means root mean square value, but the letter is root mean square value, and first is mean value. Mean value, okay, is in the denominator, and numerator is the root mean square value. So root mean square value of the ordinate is under root 2 times. Under root 2 times the mean value. Okay, this we have to calculate. We have to prove here. Okay, let me take this question. So what is the solution? Let me find out. First mean root mean square value we have to find out. Sorry, mean value. Mean value of the ordinate. I'm sorry, of the ordinate y is given by integration sign y into dx divided by dx only. Now here limits are minus pi to plus pi, and the y value is given to us. Okay, so we can take theta. This is theta. Limits are of theta here. This I'm converting into theta. So theta will be, if I take theta, okay, or r, I have changed this. R is not taken. So theta limits, if I take, this is pi by 2 minus pi by 2 plus pi by 2. Okay, so y is in terms of theta here. This is by a into 1 minus cos theta into dx. Now dx is differentiation of this value. That means a into theta, difference of theta is 1 the sin theta is cos theta into d theta now. For dx equal to d theta into d theta, a into 1 plus cos theta into d theta. Okay, this is the coordinate. Now divide by minus 5 plus 5. This is only dx here, this value a into 1 plus cos theta into d theta only. Okay, this is the mean value. Now let me further calculate this. Therefore, this sin is here. Okay, so let me now finally solve it. Minus 5 plus 5. A, this is a square now, a into this a, this is a square, let me take outside. This is 1 minus cos theta into 1 plus cos theta only into d theta divided by minus 5 plus 5, and this is 1 plus cos theta only. So differentiation, sorry, integration of this will be, let me integrate this, and here a is outside. Now integration of this 1 is theta, cos theta is sin theta, limits minus 5 to plus 5, or I can change the limits as twice 0 to pi. Let me take here, but this is definite integral formula. Okay, now still let me change this. This is twice here 0 to pi. Here also twice 0 to pi. Because from definite integral, if it is minus a to plus a, since minus a to plus a, if it is limits fx dx equal to twice 0 to pi, 0 to a, sorry, into fx dx. This is from definite integral formula. We have changed this to twice 0 to pi limits. From minus pi to plus pi, we have changed this into these limits. Okay, and here it is 1 plus cos theta, and this a is here 1 is cancelled out into d theta. Now let me further solve it. It is a only in the numerator, left over. It is 1 minus cos theta, 1 plus cos theta, that means 1 minus cos square theta into d theta, 0 to pi here, divided by, now this integration can be done. 1 integration theta plus cos theta is sin theta, limits 0 to pi. Now at pi, sin theta is 0. If I substitute the limit theta in the denominator,